Hello and welcome to Algebra II with Mr. Clausen. Today we are going to talk about algebraic expressions, and for most of you this is going to be your first lesson with me. And a couple things that I want to point out to you is that when you are in my class, since this is the first video you'll be going through, one of the things I'm going to want you to do is I'm going to want you to take notes of the material that we are covering today and in future videos. And specifically, if you are taking my class, you will have a math journal. And one thing that I would like you to do when you're watching these videos and you have your math journal is in your table of contents, I would encourage you to go and list this title in your table of contents so you know where the contents are. You can start putting page numbers and that type of thing in your table of contents as well. And if you haven't numbered any pages in your math journal yet, you can do that at this point, so that if you ever have to go back and revisit content that we talk about in these videos and you need to highlight a skill either from the perspective of a quiz or that type of thing, you can do that. Now with these videos, I will try to keep them of reasonable length. I generally aim for about 15 minutes, sometimes a little more, sometimes a little less, depending on the content. But with each video, what I will be doing is I will be targeting a specific set of skills. So for algebraic expressions for this first video, is we'll be looking at skill 1. We'll look at evaluating some simple algebraic expressions. We'll talk about evaluating algebraic expressions with absolute value and exponent pieces to it, with fractions as well, and then look at how to analyze algebraic expressions within a diagram. All right, so that should give you an idea of the skills that we're going over. And I'll go through these quickly. One of the beautiful things about a video is you can stop, pause, take your notes and that type of thing. And when you're going through these, I will allow you to have a 3" by 5" note card, one side, for each quiz that you take in my class. So this is a great time that as you're going through it and you're like, oh, I probably need to remember that. You know, take notes, highlight certain things like in your math journal so that when quiz day comes, you know, you can just fill it out on your note card, whether it's an equation or that type of thing that you think you may need to know. So with that said, let's start with the first skill. So to get started, I want to talk about how to evaluate simple algebraic expressions. And all evaluating really implies is that, you know, if you have 5y minus 3z plus 4y minus 1z minus 3y, and you have to evaluate it for when y equals 3 and z equals -2, all you're really doing is just going, oh, we're replacing all the y's with -3 or with +3, substituting those in, and we're replacing all the z's with -2's. All right, and it seems simple enough. And the one thing I'm going to tell you to do at this point is don't start plugging stuff in right away. As we get further into our math content, one of the things that you're going to want to do is you're going to want to simplify this big equation into its simplest form and kind of consolidate it before we start plugging everything in, because it might not make a huge difference in time now, but it will help a little bit, and it'll help a lot more as we get further into this content. And so what do I mean by that? So if we're looking at this, you know, I see that the variables y and z are the only two variables incorporated into this expression, all right? But we can go and take parts like 5y, 4y, and 3y, and we can combine all of those into one component. We could go 5y plus 4y minus 3y and reduce that to 6y. And if we look at the z components and we put those over here, we could go minus 3z minus 1z, and we could combine those here to get -4z. And now if we want to evaluate this, now all we have to do is substitute in the pieces that we have to evaluate, y equals 3 and z equals -2, just once each instead of 2 or 3 times. And this is a process that can make solving these given equations a lot easier. The other thing I'll do here is whenever I'm substituting in the piece to evaluate, like I'm plugging in 3 for y, I usually put it in parentheses, and that just helps me to keep track of order of operations and that I'm not accidentally putting a 6 and a 3 next to each other and accidentally seeing it as 63 or something like that. So it's one of those things I encourage you to do is use parentheses, because if you're putting it in your calculator, again, it'll help you out, and when we're looking at that, it'll make things easier. So 6 times 3, that's 18. negative 4 times negative 2 is positive 8 because the negative times the negative gives you a positive. 18 plus 8 would be 26. And then we take a larger expression and we solve it really quickly. Another example in terms of evaluating simple algebraic expressions is, let's say we have negative k squared minus, in parentheses, 3k minus 5n plus 4n. And we want to evaluate it for when k is equal to negative 1 and n is equal to negative 2. And again, I'm going to do the same thing here, but one thing I do notice is that we could plug everything in the parentheses, but remember, please excuse my dear Aunt Sally, things in parentheses have to be dealt with first. And how I'm going to deal with that in this given case is I have a negative sign here. Well, a negative sign means that this is negative 1. All right, and so what I'm going to do here is I'm going to distribute this negative 1, and I'm going to get rid of these parentheses so that all of my terms are in the same level of PEMDAS, so to speak. And so I'm going to distribute this negative 1. Sorry, that's kind of a weird looking 1. All right, maybe that's a little better, maybe not. But let's distribute this negative 1, and I'm going to rewrite this as negative k squared minus 3k. And negative 1 times negative 5n is positive 5n plus 4n. And one thing I want to point out here is we have k and we have k squared. All right, these cannot be combined. All right, so we're not going to combine these, but we can go out and combine 5n and 4n. So there's a little bit of simplification, and it's something I'm going to encourage you to do here, because as we progress through this content in Algebra 2, it will make your life easier, I promise. I'm not having you run down a rabbit hole for no reason here. But then we can go and substitute negative 1 in for k, and again, I'm going to plug negative 1 here, and I'm going to put it in parentheses and then put the squared here. All right, and I'm just replacing the variable k with a negative 1, and then we'll go negative 3, and then replacing the k with a negative 1 in parentheses. And again, that's just to make sure that I'm obeying all of my order of operations, and then a 9 with a negative 2. Okay, and this helps me out when I just go and I put the whole variable in parentheses, because now I'm not like, oh, is it negative times negative 1 and then we square that, and you know, it can make a difference as far as how it's applied here. So if we put it in parentheses, I can clearly see that this is negative 1 squared, which would be equal to 1, and if we multiply that by a negative sign, this will be negative 1. Negative 3 times negative 1, well, that's positive 3. If we go 9 times negative 2, that's negative 18. All right, and I can start doing some math. I'll see that's negative 19 plus 3. So this would be equal to negative 16 in terms of my work and where this is all coming out to. Okay, so some examples, some things to keep in mind, maybe things you've kind of forgotten about a little bit, but hopefully getting a little bit of refresher with these examples. All right. Absolute value expressions. So remember, the absolute value looks at magnitude of a given value, the distance it is from 0 on a number line per se. And so if we plug in this type of situation, one thing you can't do is you can't go and start mushing all of these absolute value expressions together. All right. And if you can simplify within an absolute value bracket, go ahead and do it. But if there isn't anything to do, x minus 1. There's only one variable and one constant. There's not a whole lot you can do here. So in this case, I'm going to just take this negative 2, all right, and I'm going to start plugging in it because it's absolute value of x plus absolute value of 2x minus the absolute value of x minus 1. And we want to evaluate it when x is equal to negative 2. That's how it would look in your textbook as far as looking at a problem. So I'm just going to go negative 2, boom, boom, plus 2 times negative 2, put that in parentheses so I don't mess up my order of operations, and then go negative 2 minus 1, all right, and absolute value of negative 2, all right, this is where we have to take this into consideration. It's a magnitude, so it's always a positive number, right? So if it's negative 2, you're just switching the sign. Negative 4, absolute value of negative 4 is positive 4, and if we look at absolute value of negative 4 is positive 4. And if we look at negative 2 minus 1, that would be negative 3. Okay, absolute value of negative 3 is 3, but there is a minus sign here, so this will be negative 3. So 6 minus 3 is equal to 3, and that's how we would evaluate this given situation. All right, another example here. So again, one thing that you're probably going to be tempted to do is just like, oh, let's plug this negative 3 in and start evaluating. And I would encourage you just to get into the habit of distributing situations where you have parentheses like this and simplifying as you can. Because as we get to harder examples, that's going to be something you have to do. It isn't necessarily something that's going to be optional. All right, unless you like spending a lot of time on harder problems. All right, so this is a skill you're going to want to go and start developing and implementing here, because it will make you faster at computing these. So in this given case, I'm going to distribute the 3 to both terms here. I'm going to distribute the -2 to both terms here. And let's rewrite it down here. So 3 times 2x is 6x, 3 times 1 is 3. -2 times x is -2x, and -2 times -3 is +6. This would be all over x plus 6, which is our denominator here. And so what I'm going to do is I'm going to combine like terms. 6x minus 2x is equal to 4x. 3 plus 6 is 9. X plus 6. And now that I have this simplified out really as much as I can, I don't see any fancy things that I can do here. Let's just plug -3 in for x. So we'll go 4, and I'll put in parentheses -3. Again, I'm just doing that as a way to keep track of things. And I'll go -3 plus 6. All right, and I'm going to go run out of space here. So 4 times -3 is -12 plus 9. So I'm now plugging in -3 in for x so I can evaluate the expression. -3 plus 6. Okay, -12 plus 9 is -3. -3 plus 6 is +3. All right, and if I simplify that out, it's -1, and that would be my answer in this given circumstance. All right, now for the hardest example that I want to talk about here. And if you forgot how to do this, that's okay. So what we're going to look at here is how we simplify a situation like this. So I'm not going to ask you to evaluate because it's just going to be too tempting to plug in the value for y. So simplification is something that I'm going to want you to do. But in this given case, what you're going to notice is that we have only one variable, but we have a variable with 2 different powers. All right, we have y squared, and we have just y to the first power. If there's no power, it's just to the first power. And this can be consolidated a little bit, but the thing that you need to do is that you need to make all the terms with the same power, like y squared, you need to make all those terms have the same common denominator. So what's the least common denominator? Well, the least common denominator is going to be the denominator that shares a multiple between the denominators present. In this case, it's going to be 3 and 4. All right, so an easy way to do this, it might not be the least common denominator, but it'll at least be a common denominator, is that if I say 3 times 4, that would equal 12. If we gave both the y squared terms a denominator of 12, that would be something that's possible based on the denominators that are already present. Okay, and all that means is that if you use the number 12, the number 12 can be factored out into a 3 and a 4 because it's made up of 3 and 4. And what that allows you to do is it allows things to be more easily canceled out and that type of thing. And again, you might not be quite sure what we're trying to imply here, and that's why we're going to go through this example. So if you want to go and you want to solve this given expression, so what I would typically do is I would rewrite this so that all the common variables are together. So for example, I would go y squared over 4 plus y squared over 3 plus y over 3 minus y over 5. And what I'm going to do is I'm going to do this half first, all right, because that is where I found a common denominator here. Denominator. All right, and so let's bring this down here, and I'm just going to look at this one half at a time. Now, what I'm going to do is I want to make both of these y squared terms have a common denominator of 12, and I know a common denominator of 12 will work because 12 incorporates a factor of 3 and 4, which are the 2 denominators I'm dealing with here. And so what I'm going to do is I'm going to go y squared over 4 plus y squared over 3. I'm just rewriting it. But what I'm going to do is I'm going to multiply both of these by like a fancy form of 1. And so what I'm going to do here is I'm going to take this number, this common denominator, and I'm going to go 12 divided by 12. So what you're going to notice here is I'm going to multiply everything by this. And I can do that because if you multiply something by 1, it's going to be the same thing. It's like saying 12 inches is in 1 foot, right? You're not changing anything. You're just sort of tweaking it a little bit, okay? So if we say 12 over 12 here and 12 over 12 here, and we multiply both of these terms by this number, my goal is here is I want to keep the 12s in place here and get rid of everything else in the denominator. So for example, I know that there's a 3 and a 4 that make up the 12. So if I cross out the 4, I can cross out the 12 here, and I know I'll have 3 left, because 3 times 4 is equal to 12. And the same thing here, if I cross out the 3, I can cross out the 12, and I know 12 is made up of 3 times 4, so I know 4 would be left. And so these guys are canceled out, and the 12s are remaining. So then I would get 3y squared, because the 3 is left over here, over 12, plus 4y squared over 12. And I can combine both of these components and say 7y squared all over 12. And I just took two kind of gross fractions here, and I made them into one. I simplified it out. And so I'm going to do the same thing here. I'm going to look at this half. I'm going to bring that down here. Now keep in mind that when we're looking at a fraction like this, it's the same process except I have different denominators. I have a 3 and a 5. So a common denominator that could be shared between a 3 and a 5, well, let's just go the simple route. All right, as long as they're small numbers, just plug them out and do this. 3 times 5 would equal 15. That would be a common denominator that could be shared between a 3 and a 5. All right, and I know this is going to be the least common denominator because 3 is a prime number and 5 is a prime number. Okay, if we're dealing with larger numbers, there is a process that you can do to simplify it out a little bit. And I'm not super concerned about that right now. Those are examples we can talk about in class if they arise, but I want to go over the mechanism of this so that you can kind of see it here. So with that said, what I'm going to do is I'm going to go y over 3 minus y over 5. And I'm going to go 15 over 15 times 15 over 15. Multiply both sides by that. And again, the whole goal here is to keep the 15s and get rid of the other components so that the denominators are shared. So cross out the 3 and the 15. If we cross out 3 from 15, 5 should be left. And if we cross out 5 from 15, 3 should be left. And again, we can go through that same process. We can go 5y over 15, which you could simplify that out and still get y over 3. But again, we're trying to get everything with the same denominator. And minus 3y over 5. Or sorry, 15. And this would give us 2y. All right, and so now that we have combined the like components, we can take this part, and we can take this part, and combine them into our final answer of 7y squared over 12 plus 2y over 15. All right. And that would be our answer in this given situation, all right? So probably one of the hard examples that we're going to talk about, but still an example we're talking about. Now, I know I'm probably kind of pushing my time constraint that I want to stick to here, but I want to hit one last example, and that's looking at implementing algebraic expressions to diagrams. So if we're looking at this given situation, one of the things that I think is valuable to be able to do is that if we're looking at, let's say, a hexagon like this that's got variables or expressions to represent the length of each side, we can take information like that and say, what is the perimeter of this? And, we could go and say the perimeter is equal to, if we start up here, we could say the perimeter is equal to w plus 5 plus w minus 2 plus w minus 2 plus w plus 5 plus w minus 2 plus w minus 2. And trust me, if you are an engineer and you have to like plug this into equations and all that type of stuff, you don't want to plug this this many times. I mean, that would just be egregious and really painful. So what you're going to do is you're going to combine the variable. All right, so there's 6 w's. We're going to combine the 6 w's, and so we can say 6w. And we can go 5 minus 2 would be 1, plus 5 is 6, minus 2 is 2. And we can go and combine all the variables and all the constants and find that the parameter of this yellow hexagon is 6w minus 2, or sorry, 6w plus 2. 6w plus 2. And we can take more complicated things and make them simpler just by rewriting them as such. Right, so these are a few things that we're going to be looking at with our first lesson in Algebra 2 here. So with that said, I hope that you found this video helpful. Please be diligent in taking your notes and bring your math journal to class tomorrow. I'll go and look at them and see if you're taking the notes so that you're ready to go and participate and go through some of the homework examples in class. And with that said, let's do some math.